I thought I'd do a pencil and paper video here as an experimental pencil and paper video. Um, let's work through an entire assessment for inclined planes, and maybe I'll post a couple of these here. Okay. You're going to get this. I left a little space at the top of the thing like this, and my idea was that you'd calculate all the things you have to do before you can solve these problems, right? So I'm going to just draw this thing on the plane, right? Okay, and remember that gravity, the mg is going to be straight down. Part of the force is acting down the plane. Part of the force is acting into the plane, right? Okay. And this part that's acting down the plane, the parallel force, this thing here is the opposite side to this angle. Here's the hypotenuse, that's the opposite side. And these angles are congruent, and so that parallel force right there is equal to mg sine theta, the hypotenuse, right? So that's going to be 3.10 times 9.81 times the sine of 51 degrees. Okay. So let's see. Got to turn on the calculator here. 3.1 times 9.81 times the sine of 51. You can almost read that, right? Okay, so let's see. There it is, right? So 23.634, I'll say, is what it is. Right? And that's going to be a key force. This guy is always down the plane, right? The force parallel. This thing is always down the plane, right? Okay? That force there will always act down the plane no matter what we're doing, right? The next force we got to figure out is the force of friction, right? And there's two forces of friction here. Let's figure out the dynamic force, the sliding force, right? So force of friction is mu times the reaction force, which in this case is this little component over here, right? And that's actually mg cos theta, right? So it's mu times mg cos theta, right? So for the dynamic friction, we'll use this. Kinetic is a synonym for dynamic, okay? So we're going to go 0.38 times 3.1 times 9.81 times the cosine of 51. Okay, now I've got that thing sitting there on my calculator. I'm going to store that in alpha A. Notice I'm already in alpha mode because this is a TI-86. You would have to type alpha. I'm just going to store that guy there, right? And now I'm going to go, here we go, and then 0.38, not cosine, but cos. Oops. There we go. So we got 0.38 times 3.1 times 9.81 times cos 51. And that's 7.2725. Right? That's my dynamic friction force, right? And this thing, the dynamic friction, opposes the slide. So if we're sliding up the plane, the dynamic friction is down the plane. If we're sliding down the plane, the dynamic friction will be up the plane. Okay, so these guys are our major players. Okay, there's that guy. There's the dynamic friction force. We just have to be able to read through the problem. First, we have to be able to calculate those successfully, right? Then we have to be able to read through the problems and decide which way these things are. Okay, now since this thing is asking us about whether the thing will stay on the plane, we also need to calculate the force of static friction. Okay, well, the force of static friction is the same as the dynamic friction, only we use the static coefficient. So let's just do that. 0.52 times 3.1 times 9.81 times cos 51. Let's do that. So I'm way too lazy to type all that stuff. Actually, I'm going to store that guy in B just for kicks, right? And then let's just change the coefficient here. I'm way too lazy to type all that stuff again, right? So that is 0.52. Oh dear. All right, times 3.1 times 9.81 times cos 51. Here we go. So that is 9.9519 newtons, right? And that is the maximum amount of force available to keep the object from sliding down the plane. Okay, so so now the question is, right, will the block stay on the plane, right? So now we can draw a little picture, right? Here's this block sitting on the plane. The parallel force here, 23.6 newtons acting down the plane. Right, that's our parallel component of the force of gravity, right? That force acting down the plane is much bigger than this static kinetic friction force, right? I'm sorry, static force, not static kinetic, right? And so really the thing just doesn't have a chance. It's not going to stay on the plane because the plane is actually much steeper than I've drawn here, right? So no, force parallel is bigger than, so force parallel of 23.6 newtons is bigger than the force of friction static with a max of 9.95 newtons. You could even add some smack talk to that, like, you know, it's much bigger, you know. There it is, right? So there's our first question, right? Okay, and then let's see the okay. So B, what is the acceleration of the block if it is sliding down the plane and there's a force up the plane? Oh my gosh. So here this thing is on the plane, right? 3.1 kilograms. And let's see, there's 9.2 newtons up the plane, right? Right? That's 9.2 newtons. Let's see, it's sliding down the plane. Okay, so if it's sliding down the plane, the force of dynamic friction, this force of 7.2725, right? That force is going to act up the plane as well, right? So we've got 7.2725 acting up the plane, right? And then of course there's always the force, the parallel force of gravity acting down the plane, right? This 23.634 newtons. Okay, so now we're all set. This guy's down the plane. The 9.2 is up the plane. The friction force is up the plane because we're sliding down the plane, right? So now we're set. We can just set this thing up, right? Minus 23 plus 9.2, right? Equals 3.1 times A, okay? So parallel force always down the plane, right? This thing is up the plane because it says up. I'm basing that on the word up. Okay. This guy is up because we're sliding down. Okay, and now all we have to do is just do some calculations. Okay, let's see. So parentheses, minus 23.634, right? Plus 9.2, plus 7.2725, right parenthesis divided by 3.1. Hopefully we'll get the right answer here. I get negative 2.31. So it's still going to accelerate down the plane. Since it's sliding down the plane, it's actually accelerating, right? And I want you to say up or down the plane, right? Down the plane. So it actually has a negative velocity and a negative acceleration. So it's actually going faster and faster, right? Yay? All right. Let's do the next one here. What is the acceleration of the block? Okay, if it's sliding up the plane. So here it is sliding up the plane, right? and there's a force of 52 newtons up the plane. Okay, so let's see. 52 newtons up the plane. Now, if it's sliding up the plane, the friction force, the 7.2725, is down the plane. Okay, that's my force of kinetic friction. Okay, we got that from here. Okay, let's go back to that. So that guy's down the plane, and then the parallel force is always down the plane. The 23.634, right? So 52 newtons up the plane, right? That guy's positive. This guy's negative. This guy's negative. And so our force equation looks like this. Minus 23.634. There goes my dog. Okay, and then we've got negative 7.2725. And then we have positive 52 equals 3.1 times A. Okay, so again, this guy is always down the plane, right? This is negative because we're sliding up the plane. If we're sliding up, this guy's down, right? This guy's positive because of the word up, right? Okay, it's pretty straightforward. When I give you outside forces, I'll just say, are they up or down the plane, right? Okay, now we're all set, right? Now we can calculate this. Okay, let's see. So parentheses, minus 23.634. And that wasn't a minus, that was a minus 7.2725 plus 52, right parenthesis, divided by 3.1. 6.80 positive, right? Right, and this is up the plane, right? Okay, so what we have is actually it's sliding up the plane. We have a positive velocity, positive acceleration, right? So this thing is definitely going faster and faster. Okay, all right. Let's do the next one. So the next ones are unknown force calculations, right? So what applied force would cause the block to slide down the plane with an acceleration of that down the plane? Let's see. Let's grab the backup pencil here. Okay, so let's see. Whoa. Okay, so slide down the plane. Let's draw a picture of that. Here it is going down the plane, right? And there's some unknown force acting on it, right? So let's just put that unknown force there. And then, of course, the parallel force would always be acting down the plane. Okay. The unknown force would act in a direction that is yet to be disclosed, right? Because it's sliding down, the kinetic friction would be up the plane. So the 7.2725 would act up the plane. That's a 7, in case you're wondering what that number is that I just drew there. Okay. So now we can set this thing up. Right, we've got the parallel force down the plane. We've got an unknown force, just always say plus F. Okay. And then we've got the force of friction, the dynamic force of friction that we, by the way, we came by that honestly. There it is, right? Okay. Don't forget, people always forget like the 9.8. That's how sad is that, right? Okay. Don't forget that, right? Okay, so here we are. So that guy is up the plane. And the reason that the friction is up the plane is that friction always opposes the direction you're sliding. So if we're sliding down, this thing's up. If we're sliding up, that thing is down. Okay? All right. Now let's see. That equals 3.1, which is our mass, right? And now we got to decide whether that acceleration is positive or negative. This one's straightforward. Okay, since it says down the plane, right, we're going to make it negative. So it's going down the plane. It's got a negative velocity and a negative acceleration. That is, it's going faster and faster down the plane. Okay, so now we can solve that. with our calculator. Okay, here we go. Here's my favorite thing to do. I just start on the right side. I go 3.1 times negative 4.5. Okay, and then I'm going to subtract this guy. So minus 7.2725. Then I'm going to add this guy. Okay. I just clear it over and I get 2.41 newtons, right? Positive 2.41 newtons. Okay, that's up the plane. So this is kind of an interesting thing, right? This block is sliding down the plane with an acceleration of 4.5 meters per second down the plane. Yet, to make that happen, you actually have to have a force, a retarding force, a force acting up the plane of 2.41 newtons. So presumably without this force, it would accelerate down the plane faster than that, right? Which is kind of interesting, right? Okay, I don't know. It's kind of interesting in a physics teacher sort of way. All right, let's do our last problem here. Okay, and the last one is, of course, very, very tricky. So what applied force would cause it to slide up the plane? So let's draw a picture of that. .1 kilograms, it's sliding up the plane. Now, if it's sliding up the plane, the parallel force is down the plane, regardless of which way it slides, right? So minus 23.634, that's just like a given, right? But there's also, if it's sliding up the plane, the kinetic friction or the dynamic friction is down the plane, right? So 7.2725. That guy's acting down the plane, right? Okay, and then there's some unknown force, right? And we'll call that F. Okay, can we see that? We can see that. There we go. So we've got the dynamic friction's down the plane because we are sliding up the plane. Okay, the parallel force is down the plane because it always is down the plane, right? Because it's part of gravity. Gravity never changes. Gravity is always down the plane. In fact, it defines the direction of down, right? The unknown force is always left as just like a positive thing, right? We just don't know which way it's going to be. In fact, in this case, it might be surprising. It might be a scandal. Okay, so now we're set. Now we can set up our little expression. We've got minus 23.634 minus 7.2725 plus F. Okay, but now we're getting to the trickiest part of this. This is the most treacherous part of this thing, right? If it's sliding up the plane, but decelerating, okay, I'm waiting for the video to catch up with me. What's it doing? It's frozen. If it's sliding up the plane, here we go, whoa. It's chunking. Okay, yeah, this pencil and paper might not be so great, right? If it's sliding up the plane with a deceleration of 1.8, right? What that means is that we've got a positive velocity but a negative acceleration. That's how we have a deceleration. Okay, so just look for that, right? The deceleration means that the acceleration is opposite the direction of the velocity. So we're sliding up the plane, which is a positive velocity. We have a negative acceleration for a deceleration, right? So bet you didn't see that one coming. Hopefully you did. Right, so this is minus 1.8. Okay, because it's sliding up but decelerating. Yeah, sliding up but decelerating. Okay, here we go. Let's try this guy. Get the calculator in there. Gotta have the calculator in there. Okay, so let's see. To do this one, I always start on this side. So I go 3.1 times negative 1.8. Okay, then I'm going to add this to both sides. So plus 7.2725. So remember, this friction is down the plane because we're sliding up the plane. Friction always opposes the slide. If we're sliding up, it's down. If we're sliding down, it's up. But in this case, we're sliding up, so it's down. Parallel force, always down the plane, right? So that plus 23.634. So basically, I start on this side, and then I just get rid of these guys by either adding or subtracting them, whatever gets rid of them. In this case, I'm adding both of them. and the force is 25.32, 25.3. And since it's positive, it's definitely up the plane, right? Okay, and these are the answers I got before, so. All right. So again, basically just work out, the first step is to be able to do these, remember these, right? That mg sine theta, okay? That guy is going to give you the force parallel to the plane. Work that out. Don't mess that up. Double check that number, right? You mess that number up, you're going to mess up the entire assessment, okay? And then figure out the force of friction, right, which is just mu, and then it's the other component. It's not mg sine theta, it's mg cos theta, right? And figure that guy out. And then, sometimes you have to find the static force of friction, right? And then just remember that the parallel force, this parallel force here, okay, is always down the plane. The kinetic friction, the dynamic friction just opposes the sliding. Read through the questions. Given forces are either given as up the plane or down the plane. So they go in there up the plane or down the plane. Okay, the parallel force is always down the plane. And then the friction force depends on which way it's sliding. If it's sliding down the plane, the friction force is up the plane. If it's sliding up the plane, waiting for the thing to move. If it's sliding up the plane, then that thing is down the plane. Okay? Unknown forces, for unknown forces, right, you always put those in as positive. This is always negative. It's always there. Every single problem has got that, right? Okay, the friction force, you got to look at which way it's sliding, right? Unknown forces are always positive, right? And then accelerations, you just have to read the problem and think through it, right? Okay, is it, if it's sliding down the plane and accelerating down the plane, then it's negative, right? If it's sliding up the plane but decelerating, it's also negative, okay? Waiting for the camera to catch up to me. It's really chunking. Wow, hasn't moved. I'm moving my pencil right now. I haven't frozen. All right. Imagine that I'm pointing at that negative 1.8 there. This is really bad. Okay. I hope that helps.